Hello, everybody. This is Jeff de la Beaujardière. Welcome to the April CISL seminar. Thank you for joining us. Our speaker today is Douglas Rao. Douglas is a research scientist at the North Carolina Institute for Climate Studies and the Cooperative Institute for Satellite and Earth System Studies in Asheville, North Carolina. He supports the development of the emerging NOAA Center for Artificial Intelligence and is also the co-lead for the ESIP Data Readiness Cluster to advance AI-ready efforts, ESIP being the Earth Science Information Partnership. Douglas is going to speak to us today on understanding the community's need for AI-ready open environmental data. So Douglas, if you're on, feel free to turn on your camera and your mic and start going. We're seeing your title slide right now.
Great, thanks, Jeff. Thanks for the invitation to present at the CISL seminar or webinar today. And today I'm going to describe some of the effort that we have been doing through ESIP's Data Readiness Cluster on understanding AI-ready data for Earth and space sciences. So here's a too long, don't read version, don't have time to read version. So the whole talk will be focusing on the broad interest in promoting AI-ready data from the broad community, not just Earth and space sciences. And from the existing work, we have seen that AI-ready data can be really challenging to define because of the dependency on different models, use cases, and data types. And so in the past several months, the ESIP Data Readiness Cluster have led a community survey to identify key aspects of AI readiness for the open environmental data. And also, I want to emphasize some of the community-driven efforts that are critical to promoting the data's AI readiness. So I just want to start the presentation with a quote from I randomly ran into on Intel's webpage, which they claim that you are not AI ready until your data is, which is a valid statement. And in their in their detailed description, they have mentioned that the biggest roadblock in implementing a proof of concept for machine learning or deep learning is to source, organize, and feed the right kind of data into the model. That is a really true statement about how oftentimes we spend a lot, as a AI machine learning model developer, we spend a lot of time to focus on the efforts of data preparation, processing, and make sure that they can fit into the model. So here is a one version of idealized AI or machine learning workflow that you may have seen other versions of it, but it's all similar with different components from all the way the initiation of the problem definition to data preparation, model training, model evaluation, to the final operation and deployment, as well as monitoring. So that's the entire operational AI machine learning workflow. But in this way, you don't really realize that how big of effort that data preparation often need to. So it's always like your plan versus reality type of thing, that in your plan, everything should move smoothly from the problem definition all the way to deploy the model and monitoring. But the reality can be much cruel than even this drawing on here. Sometimes it may sound like Dungeons and Dragons. You need to go through a different chambers to fight different beasts to get the final destination. So here, I just want to emphasize that data preparation can be often a lot of effort and time consuming to make it work for your AI machine learning workflow. But I want to do a self-defending disclaimer. This is not one-to-one scale. So please don't argue with me about how much bigger this circle of data preparation should be. So recently, I was going through one of my proposals, which was recently funded by CPO office, Climate Program Office at NOAA. And I look at the workflow, I realized that almost 70% of the boxes on this workflow are data related, from all the way to data collection to data matchup to cleaning, and then splitting them into the training, testing, and using the independent data to evaluate this machine learning model. that all those green check marks on this workflow are all data related. So if you go back to look at your workflow, if you can find less than like 30% of your workflow is data related, I would say that's a huge success already, because that removed a lot of efforts, shifted a lot of effort from the data processing to the model processing. And then I further look into one of the components that I proposed to do in this project is that I retrieve the temperature profiles from infrared sounding instruments that going back to the 1980s. And when we go into look at that data, we discovered some irregular data patterns. So that triggered a lot of data reprocessing and to make sure that the data is fit for the purpose of this project. So then I have been spending more than 8 months than I have wished for this process. So that is a late personal realization of how much effort that I personally will put into cleaning the data, make the data work for AI or machine learning application. And recently, there are a lot of talk about data-centric AI. So defined by Andrew Wang, he said that data-centric AI is a discipline of systematically engineering the data used to build an AI system. So in his view, that AI system can be split into code and data. Code is more traditional, like the models and the Python like software package you will use to develop your model. And so when in the past, a lot of AI development research have been focusing on those code piece, which is model-centric approach. And now people are more getting into the data, focusing on the data. So that is so-called the data-centric approach for AI development. And another note is that about data-centric approach, it can also help build the trust, because when we're looking into the data and to engineering and to find the most fit for purpose data, we need to understand how the data quality and how that may affect the results at the end. So that is really integral for those like trustworthy AI machine learning model developments. And in a paper published by a Google researcher in 2015, they call it the high technical debt of AI system. So in this figure from this paper from Scully et al., if you look at the machine learning code in the entire machine learning or AI system, it's a really tiny piece of this entire system. And when you look at several other major components from data collection, data verification, and feature extraction, those are really highly related to the data piece. So that is oftentimes, even for those tech companies, they need to spend a lot of effort to clean the data, make the data fit for purpose for the system. So this, they argue that this is a debt you have to pay off. And so if you can design a way to reduce the debts to make sure the system is more affordable and sustainable and too easy to maintain, that would be much better in the longer term. It is easy to do a one-off short-term development of those AI systems. So this is another evidence or argument of why we need to make sure that data is a really important piece when we're designing our machine learning development process. So speaking of all those from both research point of view and my personal experience, and then I want to switch gear to some of the top-down requirements. So this is coming from the National Artificial Intelligence Research and Development Strategic Plan, the recent update in 2019. And then they also issued a request for information early this year. So I see some of the earth science community provided feedback on those updates to the national strategy. So in this strategy, strategy 5, that there is a develop shared public data set environments for AI training and testing, especially the emphasis on one of the executive order in 2019, which is agency need to improve data and model inventory documentation to enable the discovery, usability, and also prioritize the improvement to access and the quality of AI data and models based on, I think this is really important sentence, which is the AI research community's feedback, that we can always say we did the improvement, but if the improvement is not fitting the community's feedback of the AI researchers, those improvements may not necessarily really valuable for those AI developments. So switching from the national strategy and looking at some specific responses from Earth and Space Sciences, as Jeff mentioned, I'm also supporting development of NOAA Center for AI. Now, in NOAA's AI strategic plan, it specifically outlined that NOAA need to have a coordinated approach across NOAA to effectively develop the AI-ready data and tools for reliable and efficient processing, interpretation, and utilization of Earth observation. And on the NASA end, that NASA's SMD, Science Mission Directorate, in 2021, they have an AI report, which is that NASA SMD has an opportunity to enable the greater sharing of AI-ready data and models. And AI-ready data sets can significantly lower the barrier to entry to using AI for science and allow for easier reproducibility of the results. And here you see another term come out, which is reproducibility, which is also really important to mention here. So because I'm interested in that topic, AI-ready data, I've done a lot of reading from different agencies and different groups and different researchers. And so in the United Kingdom's national AI strategy, they use slightly different words. So that's something I found really interesting. They use data foundations. So what they define as data foundations are the data that is fit for purpose and recorded in standardized formats on more than future-proof system, and fair, which is findable, accessible, interoperable, and reusable. So, but when we, for any people who are doing who start learning machine learning, that some of the data set you often hear is that iris flower data set, ImageNet, MNIST for the handwriting, and some other typical common data set that have been used for example data set for, if not like a decade, will at least be couple years. So those data sets are really highly curated, that with the target labels are well presented, and also the data set is in a format that easy to use. But when we think about those real life or real-time machine learning systems and developments, that often depends on 3 different dimensions. One is what's the use case you are specifically trying to use the AI machine learning model to address? And then what's the model techniques you're going to use? Are you using those traditional supervised or unsupervised learning method, or are you going into more deep learning and other type of methods? So, and then we also have the data types. So what are you using, the image or time series, or a combination of different data types? So that becomes very challenging task to define what AI ready means. So I think they did a really generalized way to define in this UK AI strategy, which is that they use a term called fit for purpose, which it's smart, but also hard to quantify what does really fit for purpose mean in general sense. So it's important, it's really important to leveraging those community expertise to understand how, especially for Earth and space science, can we improve our data to make it much easier for people who want to use it for AI machine learning applications to address some of the societal challenges, such as the environmental equity and the climate adaptation. So ESIP, that we think is a great opportunity and place to convene a diverse group of people, from the data users to data providers and data archive centers, and those like developers and researchers. So it's a convenient place where you can bring people from different organizations together. And both NASA, NOAA, and USGS are the sponsor of this nonprofit organization. So if you do not know this group, I highly recommend you to check it out, esipfed.org. So the ESIP data readiness cluster that I'm co-leading is have 3 self-identified goals we want to achieve. The first one is to coordinate the development of community guidelines and standards around AI-ready data. And the second goal is to enable the exchange of the experience for data curation and management as well as service, and also promote the development of the new tools and services that can enable the AI-ready data goal, and also make the researcher's life much easier to shifting from spending a lot of time on data processing to using those time more meaningfully in the model development and building a trustworthy and responsible AI applications. So if you want to find out more information about the cluster, you can go to this link on the slides. It's a ESIP wiki page about our cluster. There's a way to show you how you can join the newsletter and also how to join our monthly call. So we started our cluster in early 2021, and we have a virtual meeting session during July 2021. And we have more than 100 people join that discussion or this session. And there you can see a really strong interest from data management providers in that session. So this spider web shows that we ask the participants to identify how they classify themselves. A lot of people give themselves higher score as a data provider or manager. We also have some like AI practitioners in there, but it's more, the participants more classify themselves as data provider managers. That shows that there are broad interests, not just for the researchers, but also from the data provider side. They are also really interested in understanding what AI-ready data is, and so they can improve the data services for the community. So based on some previous work by the Office of Science Technology Policy, they have an open science subcommittee. They try to work on what AI-ready data means, but that subcommittee switched the focus and did not continue on AI-ready data. So the ESIP data readiness cluster picked it up from a draft report from the subcommittee, and we further worked on it through some discussion at the ESIP groups. So we identify AI readiness have 4 major components: from data quality, data access, data documentation, and data preparation. So for data quality, what we mean is that it has several subcomponents, including the completeness of the data and the consistency of data to make sure that it's consistent or uniform within the data sets. And then the lack of bias. And when we're talking about bias, that's a really interesting discussion we had for about 20 to 30 minutes, because from different subdisciplines, even within the earth and space science, that people have different understanding of what bias means. For people who are doing the observation, talking with the people who are doing the climate modeling, the bias perception is different. And then timeliness, which is that can be an issue for some of the applications if it requires much lower latency of the data, and the provenance of the data and integrity, and the size and uncertainty quantification. So that's data quality. And for data access, that we identify the formats and delivery options, usage rights, for example, the licenses. And also for some restricted data, for example, within NOAA, there's those protected species data that you don't want to make it completely public, so that the security and privacy can be an issue regarding to the data access for AI machine learning applications. So for data documentation, sorry, I did not change the title, that's an issue. For data documentation, that we have tools, examples, which is that can we provide code, notebooks, or tutorials on making sure users can use that data, and the dataset metadata, a dictionary, which is the information about each parameters within the dataset, and identifier, so can users easily identify the datasets, the data license, and the recommendations and examples of how to use the data. The one last piece that is unique for the AI machine learning application to some extent is that sometimes people require, especially for supervised learning, that requires features being labeled or tagged, and then the recommended data splits, based on some of the interview that OSP have done with the AI researchers, that some people requested the recommended data split between training, validation, and testing, and missing values, outliers, and recommendation of how to use that data for those machine learning models, and identifying the past usage of those data set in some machine learning applications. So going back to the multiple dimension of those modeling techniques, use cases, and data types, that we realize that there's no one size fits all solution for the AI ready data. So it has to be prioritizing some things that can be universally applied to some data set, and then some part of the data readiness characteristics can become a label or tag attached to the data set that allow users to easily sift through those different data type or different data set for their application. So I recently discovered this quote from Francosis, from the creator of the Keras and the author of Deep Learning with Python. So the quote is that in general, there's very little research done on best practice for data curation, cleaning, and notation. And even though the steps have far more impact on the application than incremental architecture improvements, but this final sentence makes me laugh, that preparing the data is an exercise left to the readers. That is, sometimes it's a true statement, but sometimes a sad statement to make. So to further understand what AI-ready data really means from the AI practitioner's point of view, so the group designed the survey. We also got some great feedback from Julie DeMoose and Ann Bostrom from AI2ES. Thanks for their comments on the survey design as well. And we have target audience for AI practitioners. And the objective for this survey is trying to identify the information about which data factors that can enable the AI development or sometimes prohibit the development, so can inform our AI-ready data definition efforts. We, in 3 months, we got about 104 responses, and separated by different sectors, 40 from government, 41 from academic institutions, and 23 from private sectors. There is slight bias towards governments and academic, that as way to say that we do not have, we want to engage more with private sector. We did some targeted outreach, but we also want to hear more about private sector. That's something we're trying to do right now as well. So the question category, we have 7 categories, from background to workflow questions, and they 4 different major components of AI readiness. And then last is the specifically focused on training data. That's in collaboration with NASA's Earth Science Data System Working Group on the data interoperability for machine learning training data. So here is a quick overview of our survey responses. That for the computing environments, more than about half of the respondents said that they're still using those local environments, and some about 20% and 20% said that they're using HPC or using a cloud for their machine learning or AI system developments. For data access method, that we see an overwhelming response of they are still preferring to use, they're still using file download option as one of the options for data access. And we have roughly about 20% for API access and cloud-based access. And for the model types, that we have a majority of people using the supervised learning method, but we also have roughly 50% of the people who say that they use unsupervised learning methods in their application of environmental data for the AI and machine learning systems. So for the domain, we ask the respondents to specify which subdomain within the Earth and space sciences they're working on. So we see a quite widespread of those domain within Earth and space science, with a slightly preference for weather climates in this respondents. And we also have those biology, fishery people responded to the survey, ecologists. And methodology refers to people who focus on the method development. So they do not have really specific scientific domain application, but more focusing on the model and technology development. So now the first thing what we did is that in the survey, we asked how much of their efforts are spent on the data work. So we often have heard the statement of like 80% of the data scientist efforts have been spent on data preparation. So we want to validate that statement because it's hard to find the concrete reference of the survey that they have done in there. So in our survey results that we confirmed the similar pattern with the open environmental data users, that more than half reported that they at least half of their time have been spent on the data work in their entire machine learning workflow. And I think that might speaks to some of the really well-developed tools within Earth and Space Science. For example, the Pangeo ecosystem has been a lifesaver for many people to use those. And now Pangeo is specifically focusing on some tool addition and modification or improvements to make the machine learning development much easier. The Pangeo ML funded by NASA Access projects. So let's go into the data quality factors. So within the survey results, we ask people to choose the top 3 factors within data quality that they think is most important for them. So when you're looking at these results, that you can see that data consistency as the number 1, the winner of this category, if we consider it as a competition. And the completeness is also a really important piece for some of the respondents. And in those open-ended questions, we ask people to provide their feedback. So we just added a quote here, which is that complete and consistent data sets are even more important in AI and machine learning projects. And previously, the respondents said that it is important for other applications as well, but it's even more important in those AI application developments. So when we're looking at the data documentation, that overwhelmingly people said that dataset metadata is really important. So we need a really proper data documentation on both the data set. There are also a high demand of those parameters defined, which is sometimes people call it like data dictionary, which is that variables are well defined so users can easily understand what those parameters are for, and they can decide whether to use it or not. And the other thing that rises to the top is the code and notebooks. So the respondents have requested the tools to use the data. So not just a documentation of the data, but how user can use the data. So if there are sample codes or the notebooks, that will be a much better situation that users will be in. So here is another quote from the free text. The lack of proper documentation is one of the most widespread issues that exists currently. I cannot agree with that more. Sometimes when you go to FTP, that trying to find the data from a data page, that oftentimes you need to spend a day, sometimes a week, to figure out if that data is useful for your application or not. That it's not a situation what we want to put the researchers and users in. So when we're looking at the data preparation factors, 3 types of data preparation are most requested from the respondents that we have within this 104 responses. So one is the gridded data, and the other one is targets being labeled, and the last one, or the third one, not last one, the outlier is tagged. So they said it's tagged, but you don't have to remove it. The users can decide whether they want to remove that outlier or not. Or sometimes the information is in the outlier. So people say outliers should be kept in there, but it should be flagged and outlined. So I think that speaks to some of the existing data management practice, that the quality flag, but the issue becomes how we can represent those quality in a way that's easy for users to find. For anyone who use Modus satellite products, that oftentimes they have a quality flag that is like bit-based, that you need to decipher the quality flag of each bit to decide which data you can use or not. That is not a situation we want to put the users in. So how we can easily translate those quality information to a way that they can easily use, that would be great. So we also look at different data formats, and also separate them by those preferred data delivery methods. So one pattern that I want to emphasize here is that there are several types of data formats that's most welcomed by the users. One is the HDF5, NetCDF, and then structured text, which include both the CSV, TSV, and some other, those can easy for users to understand the data. So these are the most popular data types, data formats that users have, respondents have identified. And then for GeoTIFF, that is also a good data format that there are a lot of people said they are okay to use those data formats. And when we're looking at some of those like cloud-specific data formats, one thing is that not all users or researchers are really familiar with those data formats. And then for those more popular data format like ZAR, then we can see that you have a lot of adoption of the ZAR formats in their machine learning workflows. And I don't want to call out any specific data types, but some traditional data types, like the binary ones, have been like ranked really low on this figure. I will not spell out those data formats because I know many of you on this webinar may have like nightmare stories about those data formats. And going back to the training data side, that we are asking the respondents to respond, have they reused their own training data, other people's training data, or share their training data with others. So the two major points jumped out is that one, that people think the lack of provenance of those training data set and how they're generated is a big issue, because oftentimes when you are reusing the training data, you're not necessarily repeating the exact same task. Sometimes you want to add additional data sets into those training data sets for your applications. So if you do not know how the training data sets are generated, then it will be really hard for you to incorporate other data sets into this existing training data. So that makes it hard to reuse, and sometimes people just start from scratch to do that. And then the other thing people have emphasized is the quality of training data set is really important, because for any machine learning model, if the training data quality is bad, the model performance will not be that good in general. So there are some exciting development internationally. So the European Space Agency, they have some effort called AI Ready Earth Observation, so AIREO. And if you need more acronyms, and they have a specification for training data that is called, they have separated the predictive features and reference data, but providing a mapping between those predictive features and the reference data. So in a way, you can separate those two components. Maybe you only want to reuse part of it and then combine it with your own data sets. And documentation is another focus from NASA group, from the ESIP group on this. So they are actually developing a platform trying to share the AI ready Earth observation training data sets currently. So I would really love to see more development from that group. So I just want to summarize some of the open-ended questions, so that we have got a lot of open-ended free text comments. And so, for example, regarding formats, people have commented on AI-ready data as parallel-ready data, which can be really true, especially when the deep learning models becomes more and more common in the application or developments. So you want to make sure that those large-scale data can be easily parallelized for those model development process. And for documentation, that we see the comment about open documentation with example code, again, emphasizing those code tutorial notebooks is really important to make sure that users understand how to use data. And an anecdotal story, I have a current student intern working with me to work with some CISL data. She comes from computer science background and do not really know how to use the NetCDF data. And so once we provided her with some notebooks using the X-array and other to work with those data, she is able to get onto some processing really fast. So providing those example code and tutorials is a really good way to get a user to start using that. And so for quality and documentation, that some people made a comment that they cannot use the data set, it just doesn't have the right content. So that speaks to the documentation. So if we can provide documentation that let the users easily identify if they have the right content in the data set, would be much helpful for them. And also having all that information readily available speeds up the data discovery a lot. And access that people are saying, because they're concerned about reproducibility, so they are reluctant to use the data that haven't been downloaded by themselves, which is something like made me to think that if, especially when we're moving to the cloud, how we can make sure to ensure reproducibility of some of the concerns of the researchers. And for the quality that we want to, as some users said, the comprehensiveness is really important. So now we have the survey results, and now what? And thus I just want to use XKCD comic here that we originally said that we need to develop a new AI-ready data standards, but seeing this XKCD comic made me start thinking, do we need a new data standard or new definition? Or can we look back into some existing data standards or data management requirements to see if there's any gaps between the AI-ready data survey results we have and those existing things. So we're not duplicating the efforts, but identifying and focusing on those gaps between those existing standards or management practice or whatever you want to call it. So now we're looking at different things. So we have FAIR principle, we have analysis-ready data. Specifically, when we're talking about Earth observation, we have the CISL ARD specification. Within NOAA, there is also the data stewardship maturity metrics. And for climates, a lot of geoscience data that is following the CF metadata convention. I put 2 CF metadata convention. But for the AI-ready data, that there are 3 components, in my opinion, which is that modernizing the data management and then improving data infrastructure that can accommodate for the new and improve the data sets. And then the last one is to customize the data service. Again, going back to that, it's really, sometimes it can be really use case specific for what AI-ready means for the users. So we have to make a compromise of what data providers or the data owners can provide to start people with. And then the last mile issue of those AI-ready, readying your data for AI model becomes customizable data service, or those data tools can make that data in a fit for purpose format. So we started to crosswalk with those some existing data management practice, such as the data stewardship maturity metrics, that it has different levels and different components. So from here, one glimpse, you can easily identify the accessibility, usability can overlap with the data access and documentation component of AI-ready data. And then there are different components in the DSMM about data quality, assurance, control, monitoring, assessments that overlaps with data quality within the AI-ready data. And then the transparency, data integrity goes with the data quality as well as the documentation. So now we see there is some overlapping piece between the existing efforts and the user's requirements from the AI researchers. So the next step is to identifying the gaps and to make sure anything developed after the survey and crosswalk will be a complementary to existing and easy to leverage those existing efforts. So within NOAA, there is some internal assessments of 25 NOAA dataset in August last year. So here we have a rubric of how to ask each data owners or providers to assess that. And our next step is trying to assess some existing data set that have been evaluated using the DSMM. So to see, oh, if this evaluation result of AI-ready data as well as the DSMM, how different are they? And what's the gaps between those two? And we can focusing on producing the guidelines or recommendations on those. So AI-ready data, for those data for the ESIP data readiness cluster, there are different end goals. The first we are achieving is the AI readiness report and checklist. And next step we're moving forward is to, based on this AI readiness report and checklist, we want to produce a recommendation community guideline of how to ensure the baseline AI readiness and for reducing the effort that the researchers and users need for the AI ready for the AI application. Next step becomes the thematic data collection, so which is bringing the community together to assess and curate a set of data, AI-ready data under certain themes, for example, like the climate or fire weather and other topics. And next stage will becomes to develop community standard when after we understand how AI readiness are different from existing efforts. And then they will move on to those community standard development. And last one is that focusing on the tools and service development to address the last mile issue, right? That I mentioned that we have a baseline AI readiness, and then the last mile issue becomes more customization solution for those developers. So this is final, the last two slides in this talk, which is that in the Deloitte, they have an AI readiness in government. So it plot the scope of efforts of investment and also the potential values from the single point AI machine learning solution all the way to transformative, that basically infusing AI into all components of the agency or organization. But data is at the core of any of those efforts, right? That even for those single point solutions, you need to improve your data for that. And if you really want to become transformative efforts or value for the organization, the data, AI-ready data is definitely much more important as well. And with Earth and Space Science, that we have a long-standing open data and sharing practice. And so we can really build on those legacy and try to contribute to the AI-ready data efforts. But that really requires community-driven approach for those AI-ready data movement. Especially, we don't want to see that different groups are working on a separate thing and cannot really converge or cannot interoperate with each other. So even within the broad research community, within Research Data Alliance, there's now a new group forming that is the FAIR for machine learning, that focusing on how we can adopt a FAIR principle for machine learning. So if anyone is interested in that group, happy to talk more about that group as well. So this is a final slides and also an open invitation. So if you are interested that we at ESIP July meeting in Pittsburgh, Pennsylvania, we are organizing an AI-ready datathon. So trying to start assessment and development of a thematic collection of AI-ready data. So these are some confirmed participating groups, and NCAI is part of it, and USGS, and also NASA's Earth Science Data System groups as well. So if any of you are interested, please reach out or just pay attention to the ESIP July meeting agenda that you can just join there. I think that's all for my slides presentation.
Great, Douglas, thank you very much. For the people who are online via the live stream, please go to Slido at the bottom and you can add your questions there. Douglas, I'll read out any questions we have. So from Alex Merose, he says transformative. Is that pun intended? I guess you use that.
I did not think about that, but maybe.
Yeah, right. That transformative science by transforming our data. Yep. Second question here. As operators of a data repository, so I'm thinking kind of specifically of our division, we have some data repositories. We can work on making the data standardized, documented, accessible. You know, we can kind of try to be fair with our data, follow the FAIR principles. But it's hard to know how far to actually go in that direction or if we've gone far enough. So is there any scoring rubric we could apply to evaluate how good a data set is in these various areas? And could we advertise the scores in our data catalogs? Later, after I kind of first formulated this question, you start talking about the data stewardship maturity matrix. And I was wondering, can that be automated, or is that really a manual process? It would be nice to be able to just sort of run through all of the data and give everything a score and say, this is, you know, very standardized, very well documented. This is not so good in that respect.
Thanks, Jeff. Yeah, that's a great question. We have been talking about how we want to present the AI readiness, right? We have a checklist that's what we do to do the assessments for some of the existing NOAA data set. Let me bring back my slides. So here that with this assessment slides that we basically grab the AI readiness checklist that we have and put them into a rubric for assessment. So for the data quality, we ask those are yes and no questions that for them to assess. And this is the first step. And for, like you said, we really want it becomes automatic assessments as much as possible. And that I know DSMM, which is included in the one-stop system within NOAA. So that some of the assessments, they have a checklist. So when you, they have a drop-down menu when every time you put in a data set, I think you have to select that. And I think they are trying to develop how can use some existing metadata to autofill those information rather than using those manual process. And so that is something that AI readiness should also think about, which is that I think it all goes back to documentation. So if you have a really good high quality metadata, some of those questions can be answered just by using the code to go through the metadata. Once you go through that, part of it can be scored or checked by directly doing that. And then the other part, I think there will be like two parts. One is automatic mode, and the other one is still requires some human interaction in it to make sure that need to, for example, the labels of, the word doesn't come into my mind right now, but yeah, part of it becomes, so reduce the human effort is something what we're trying to do, yeah.
Okay, thank you. Let's see, Tasia, can you put back on the questions here? There we go. Okay. Ulrike asks, are the survey results available somewhere? Yeah, a very interesting survey. How can we get a copy of that?
The survey result will be released this month, so that we will share that survey response on the ESIP cluster wiki page, and also share it out through the ESIP channels. So and also feel free to send me an email. I can make sure that I send that survey result to you as well.
Okay, thank you. Let's see, next question. Xianghua asks, nice talk. What are your thoughts on the data-centric AI for the Earth system community? Should we pursue this currently with model-centric AI?
I think AI-ready data effort is part of it to pursue the data-centric, so that improving the data, Earth science, system science data for that. And I think it will be a combined approaches because right now, oftentimes we're just grabbing off-the-shelf model from the computer science or AI field, and oftentimes we still need to do some customization for our own purpose. Like some serial group have produced those customized loss function for machine learning for the neural networks. Those are one of the customization we need to do for our model for the Earth system communities. So I think it's both ways to do it. So I don't think we are at a stage where we can ban the model-centric AI at the current stage, because there are a lot of things need to be customized from the computer science field.
Okay, thank you. Let's see, next question from Brian Bonlander. Could you remind us how to separate data format issues from the common models that use them? I'm thinking specifically of WRF, that's the weather research framework, which uses gridded data, but researchers may prefer seeing the data in GRIB format rather than ZAR. It seems difficult to make data independent of the models.
That's a good question. I think there are some movement of trying to trying to preserve the data in its native formats, but then providing those tools and services that you can read them into a more in a more efficient way. So ZAR. So I think I forgot which package, what packages got called, but within a Pangeo community, they have been trying to say, let's just keep the NetCDF in its original formats, but then when we read it into optimize the chunking and through that package. So I can find that link to the package. And so I think there are movement of preserving the data in the original formats, but providing tools and services make it more user-friendly.
Just to follow on to what you were saying, is the package you're thinking of the one called NCZAR?
No, not that one. So let me try to find it right now.
Okay.
When you're asking the question.
All right, we can make sure the answer gets out. So last question I'm seeing here, but please, again, we do have a few more minutes. So if you have additional questions, put them on. And I'm sorry, by the way, Douglas, that since we're in this kind of virtual mode, we can't all be just kind of clustering around and, seeing each other and having a more free flow conversation than the Slido questions, but that's how it is right now. So we have data in our repositories, but we are not AI scientists. We'd be very glad to have our data used in an AI context. So kind of two questions. How can we find out if anybody wants to use our data holdings for AI? If they're just sort of downloading anonymously, we have no idea whether it's for AI or for anything else. And then secondly, is there a forum to iterate on requirements and improvements with actual AI practitioners? Something where people could say, hey, I wanted to use your data for AI, but it wasn't ready enough because you didn't do this, and maybe we can make some improvements and sort of iterate on the quality for AI uses.
I think the forum question is a really good question. I think now there's much more like interdisciplinary approach on that. And a lot of people, if you go to ICML, that you will usually have those like climate change AI like workshops. So that's when those AI practitioners, AI developers, and those climate scientists will come together. So that's a good places. And the other one, climate informatics, and it has been run by at NCAR for almost 8 or 10 years, and we're hosting it in Asheville this year in May. So that is a group that we can bring people from developers of AI models, as well as the AI climate scientists on that. So there are emerging groups, and I think there's no central place, like you said, that's one issue. But within ESIP, there is a machine learning cluster that a lot of times that bringing machine learning developers as well as the earth science data practitioners there. So, and Pangeo is another great community to be involved in it. Like Pangeo ML, Pangeo has a machine learning working group there. David Gagne is the co-chair or like co-lead for the Pangeo ML group, and Joe from NCAR Carbon Plan is also
Joe Hammond.
Yeah, Joe Hammond. Yeah.
Yeah. Okay, thank you. I think we've had some interaction with some of those forums, but they tend to be general. We're talking about the concept, and it's not somebody saying, I tried to use Dataset A and it was lousy because it was missing some things. And so now let's kind of help iterate on that. But I think we have reached, I don't see any more questions in the Slido. Nope. So, okay, Douglas, thank you very much.
I just want to respond to Brian's question, which is the package I forgot the name is Kerchunk.
Oh, yeah.
Yeah, Kerchunk is a package that people have been keeping the data on the cloud as its original native format, but then using Kerchunk to make it efficient in the computing and processing.
Is it only for NetCDF, or does it actually apply to some of these formats that scored lower on your survey in terms of population?
They are definitely want to expand into a much more data formats, not just, it started with HDF and NetCDF. I think they are expanding it. I haven't followed up on most recent developments.
Great. Okay, so seeing no further questions, Douglas, thank you again for being our speaker. Hope we can see you in person sometime, maybe at the July ESIP meeting.
Yeah.
And great, thanks again. And thanks everybody out there in broadcast land who was tuning in. See you next time.
Thanks, Jeff.